All right, now this is going to be Chapter 4 practice test for Test 3. So we're going to look at some problems. I've selected some. I'm not going to go over every one of these questions. There's 40 questions that are here. I'm only going to go over a couple. So you have quite a bit of exercise that can help you understand some of the material that we're looking for, right? But let's take a look at question number 5. All right. It says find a vertical orientation, vertex, y-intercept, and x-intercept of the parabola that is defined by the following quadratic function. Graph the parabola, identify the domain and range of the function of f. Now, you've been reviewing and practicing some of these things. So based off of the leading coefficient, the a value, okay, the a value being positive here, all right, and that positive a value is the value that's in front of the x squared, okay? So now if this number is positive, then it's an upward bound parabola, and we've reviewed this before in a lesson, right? So this one's up if it's positive. If it's negative, if the constant in front of the variable x squared is negative, then it'll open down, and that's why it's called downward parabola. All right, so this one's upward. All right, now determine the vertex. Now the vertex, determination of the vertex is negative b over 2a, gives you the axis of symmetry, as well as the x value of our vertex. And by placing it back into the function, it gives us our y output. And this becomes the vertex. So now we just take the opposite of -4 is +4, divided by 2 times 1 is 2, and then we're going to get the value of 2. So now that would be the x value of our vertex. The y value, we insert it back into the equation, we get 2 squared is 4 times 2 here, and then plus 3. So this is going to be 4 minus 8 plus 3, and this is -4 plus 3, and that equals -1. So our coordinate point for our vertex is 2, -1. Now, is the vertex a maximum or minimum? Depends on if it's upward or downward bound. Everything's dependent on that. If it's a downward bound parabola, it would be a maximum. If it's an upward bound parabola, which this is, it would be a minimum. Determine the y-intercept. Now, the y-intercept is always the c value of an equation in the form of ax squared plus bx plus c. Here is the value of our y-intercept. So it's 3. Now, always the y-intercept is founded by letting x equal 0. So wouldn't it then be easy enough just to say this is 0, this is 0, the value of the y-intercept is 3? Determine the x-intercepts. Now, this is a matter of going ahead and setting y equal to 0, factoring if needed, or putting into a graphing calculator and solving it that way. Now, because this is easily factorable, I would go ahead and determine that the easiest way to do it is just by simply not using the calculator, but going ahead and saying that it's x minus 3 and x minus 1. All right, so here we have. And so that means that x equals +3 and +1. So our x-intercepts are 3, 0, and 1, 0, because the y values have to be 0 in order to get those values. Now, determine the axis of symmetry. It is always the same thing as whatever you write for the x value of our vertex. So it's the same value. So it's going to be x equals 2. Now, always write it as an equation, not as a number, okay? Now, graphing the parabola, is simply just by putting those points in there and selecting the proper parabola. I'm going to let the system just show you that it looks like this. I'm not going to physically take time to do that. Now, the domain of all parabolas is negative infinity to positive infinity. And the range is going to be from the lowest point to the highest point, which is -1 inclusive. So it's going to be -1 inclusive all the way to infinity. All right, just, I mean, like I said, I can just show you here, it's going to be the same exact answer. Okay. However, when I wrote it down, I didn't write the negative sign. So it's obviously -1, not +1. All right, and that is question of concern for the support of the getting ready for the test. All right, number 9. Now this question, I want to go ahead and explain. It says let W be the width of the enclosure and let L be the length of the enclosure. Now it says write the function for the area of the enclosure in terms of W. Now it says that there are only 3 sides of this fence required. So that means the perimeter formula would be then L, because there's only one L you see in the picture, plus 2W equals the perimeter value of 550 feet. All right. Now the area still remains, though, length times width equals area. So what we do is we take and move this over to the other side and make it become L equals 550 minus 2W. And if we then replace the value of L in our problem with the value of what L now represents, we can find the following, that W times 550 minus 2W is equal to 8, and they want the maximum area. All right, they say find the dimensions of the maximum area. So we're going to be determining what the max is. So, and that the way to do that is, well, first of all, we're going to go ahead and do this distributive property. We're going to get -2W squared plus W. All right. And then again, we're looking for the max. And to determine what the max is, we go ahead and then use -b over 2a. Because now this is an inverted parabola. All right. So we're looking at a function of when does this occur. Okay. So that's what point of interest we have. Okay. So we use the formula just to determine what the value of the W is going to be. So it's going to be -550. All right. And then 2 times -2 is -4. And then 450, or excuse me, 550 divided by 4 equals 137.5. Now that is the W value. Okay, so that's the W value. Now what we're going to do is, because that's the maximum value, we're going to reinsert that into here, all right, to find out the length. That's how we're going to determine that. So you can just use your calculator, but it's going to set up, it's going to be 550 minus 2 times 137.5. And that's going to give us our L. So I'll just punch it in a calculator. 550 minus 2 times 137.5, and we'll get 275. So now to find the maximum area, all right, because that's what we're looking for, the max area is taking this times this and gives us the maximum area. So 137, or yeah, 137.5 times 275. And then the maximum area, A, will be equal to 37,812.5. And there's all the answers we're looking for. So here is that one. All right, that's that one. And then the feet for the maximum is right there. And the length is right there. All right, and the maximum area is right there. So this is pretty straightforward. I've given this to you in an introduction to one of the lessons. I was like, I tried to challenge you and having you figure it out on your own first. But I figured, because I knew it was coming up on this, and I explained it. All right, now let's take a look at number 10. Now it says a quadratic function has a vertex at such point. The function passes through such point, and when written in standard form, such where blank. Okay. Now we want to go ahead and write it into the system. So now it says it's passing through the point of 2, -5, and -9. That has a vertex of such that vertex point is 4, 5. So when we're going ahead and calculating this, right? We're going to go ahead and do this. We're not concerned about the A. We're going to find that out later by using the point. Okay. Now we're going to go ahead and place in there the value of our H, which is 4 squared, and then our X, or K, excuse me, which is +5. Now we can't determine the A until we place in the point that's passing through, and that is that it's passing through the point of -9 equals A, and then we have 2 minus 4 squared plus 5. So we're going to go ahead and subtract 5 from both sides, get -14, and then go ahead and do 2 minus 4 is -2 squared is -4, or excuse me, +4. Okay, because it's -2 squared is -2 times -2 is 4 times A, and then divide both sides by 4, and then we get -7/2 for A. So then we need to come up with an equation, all right, where, so some text refers to this as the vertex form, while others refer to it as standard form. Either term is acceptable. We go ahead and generate the value system of this, replaced in for that, and then that gives us our answer. All right, so it's a matter of using the vertex, which is the X or the H and the K, and then using the point to determine what the A value is. All right. Number 11. This one was given to you, before, where it was in your homework, but it says if R is a 0 of even multiplicity, then it will turn around, touches it and turns around. All right, it touches it and turns around. Whereas if it's an odd multiplicity, it's going to go ahead and cross over the x-axis. Number 16. It says use the leading coefficient test to determine the end behavior of the graph of S. Now, the leading coefficient is going to be the negative sign, negative number. So that means that we have a situation where whatever we determine as the output, we're going to reverse it. Now, here's the thing. Since this is all multiplying, it's going to be x to the second times x to the third times x to the first, and so that's going to be x to the sixth. Since it's x to the sixth of some magnitude I don't care about, I'm going to go ahead and understand that this is an even function and that it's opening down in both sections, left and right. So it falls to the left and falls to the right. And that's what this is saying right here. Falls to the left, falls to the right. Now it says determine the roots of S. Enter solutions using comma separated list. It's going to be 0, 5, and -4. All right. That's just a matter of setting each of these equal to 0. You can do that mentally. It doesn't matter about the multiplicity at that moment. All right. Now the multiplicity of the least root, which is the smallest root, is going to be -4. All right. And that multiplicity is to the first power. The multiplicity of the greatest root, which is 5, is going to be 3. Because there's 3 roots there. It says it right there in the problem. There's not much I can have to write here. I mean, I extended my efforts trying to write here. This is just understanding. The multiplicity of the root, which is going to be 0, is going to be 2. All right. Now, at the least root, which is the -4, all right, the graph is going to do what? Since it's only a multiplicity of 1, it's going to cross over that particular x value. The greatest root, 5, which, I mean, if you can't, this is like repeating itself a little bit here, so this should be all the same answers. It's going to turn around at that point. No, excuse me. It's going to cross over that point since it's an odd root. All right, so that's also crossing. And then the other root, 0, it will then touch and turn at that point. Now determine the y-intercept. Now you go ahead and allow x equals 0, and you can go ahead and determine the y value. Okay, so you go ahead and plug in. Where is that problem? Okay, I've already done all this. So you go ahead and plug in the y-intercept, and it's going to be 0, 0. Determine if the function is even or odd or neither. Now the thing is that with such a graph is given here, all right, we could go ahead and graph it, and graphing it will lead us to realize that it's one of these graphs down here. And the best thing to do to have this kind of graph is to go ahead and put it in your graphing calculator. However, we know that it's not going to be an even or odd function because it doesn't have any symmetry. So this is going to be neither. All right, now selecting it, we know that the darn thing is going through these 2 points right here, as well as crossing, or excuse me, turning around at 0. So we're looking at, okay, so it's coming in. First of all, it's odd. No, it's not odd. It's even, excuse me. It's even and falling to the left and it's falling to the right. So it's going to have to be one of these, this one or this one. It can't be this one or this one because they're both, it's an upward bound parabola. Now it's turning around at this point, which is good, and also turning around at this point. Now it crossing over at certain other values, it's crossing over at +5 and -4. So whereas it crossing over at that, it's not crossing over at -4 here. All right. As a matter of fact, it's not crossing that over 5 over here either. So this one's a throwaway. So then your answer will be this one because it's crossing over at 5, crossing over at -4. So that will be our answer. So we didn't have to go ahead and physically write it down. Okay, we didn't have to physically even put it in the graphing calculator. Okay, we can determine it based off of the information given. All right, so that's how you handle that kind of situation. Now 19 says the graph of f below is complete. All right, now since it displays all zeros in the end behavior and the y-intercept of the graph of f. Use the graph of the f to answer the following questions. List all zeros with even multiplicity. If more than one such zero exists, use a comma to separate the list to answer the zeros. So now we're looking at x here even at -4 because it turns around at -4. Now it crosses over at -1. So it's crossing over at -1. That's going to be an odd multiplicity. So the -1 is defined. Determine the y-intercept. The y-intercept is going to be at 8. So it's nice when we have the graph. Determine the factor form of the polynomial function. So we have the -4 and the 1 being that since we want the factor form, we would go ahead and put this, right? So we have that written like that. Now the thing is that, okay, we have this component, all right? How do we determine A? You go ahead and again, choose a point of interest. Since we have the y-intercept, we can go ahead and determine that since we know this, we'd have an undetermined value of A, and we can use the point of the y-intercept to find that out, because all we got to do is let x equal 0 and let this equal to the value of our interest, which is 8. So we can go ahead and determine the A value by just simply going ahead and plugging in 0 for this. So 4 squared, all right, is 16. And then we put in 0 here, that's 1. And 1 times anything is itself, so we don't even care about the 1 anymore. But then we divide both sides by 16, and there's the 1/2. That's how we get 1/2 for our A value. All right, because we have to put it in that form. You know, that's the form we needed. All right, number 20. Now, number 20 is using synthetic division. So remembering, you have to take the opposite of whatever value is showing there, put it in a half box like such, and then make sure that you're in order, which we're not. So we're going to put in order when I write it. So it's going to be 3, 20, 7, and -18. Now we know this is, we don't know this is a 0, actually. It doesn't say that. It is a 0. So we're going to drop, multiply, add, multiply, add, multiply, add, and then we're going to get our answer of 3x squared plus 2x minus 5 with a remainder of positive 12 over x plus 6. So we're looking at that for our answer here with a remainder of 12 over what we divided by, the divisor. All right, so that was pretty straightforward and easy, I think, in my opinion. Now 23. Now 23 says use the rational root theorem. Now remembering, it's the factors of the constant over the factors of the leading coefficient. And we got to make sure that we're in order, proper descending order. All right, in order to do this. So we're going to go ahead and determine that it's going to be plus or minus 1. Remember what I told you about before on this one. Plus or minus 2, plus or minus 5, and plus or minus 10. It's all over plus or minus 1. Anytime it's plus or minus 1, it's the value system that we're looking for is this one. Now remember, they want it all separated, so when you put it in the system, it must be separated. And from this recording alone, I will then tell you that it will, I will not accept it if it's not separated, because that's the only way you're going to get credit for it. So I'm writing it down for you. All right, so that's how it's going to be listed. All right, now it says use synthetic division or other various methods, which we're going to use the graphic calculator, to determine the actual roots. So I taught you before that we want to just go to a calculator. So it's x to the third minus 6x to the second plus 3x plus 10. We graph it, all right, and then we go ahead and second graph allows us to find the zeros rather quickly because all we're looking for is where is it 0 on y. And so it's 0 here, so it's at -1, 2, and then we have another one at 5. So those are our zeros. All right, so we're going to look at -1, what did I say, 2, and 5. All right, those are all our 3 roots. And those are the answers that are provided here. So you can use your graphic calculator. You know, I authorize that in every single one of your tests. So look how fast that was. Question number 31. A graph of a function is given. Determine the equation of the vertical asymptote. Remember, the vertical asymptote is where the function cannot be compromised. So we're looking at x equals -3. That's the vertical asymptote. It's where the dashed red line is. Now the horizontal asymptote is where the red horizontal line is, and it always starts out with y equals, and that is that value 2. And the domain of all these functions is always going to be where it can't compromise the vertical asymptote, so it's going to be from -infinity to -3, skips over it, and picks it back up from -3 on to infinity. All right, so there's our values we're looking for. All right, and that's all. That's all this one was about. So that one's pretty straightforward and easy. All right, now for this one, it says analyze the following. All right, so we have -4x over -5x minus 20. So what we can do is try to simplify this if we want to, but we got to go ahead and set the denominator equal to 0. And we get our answer of x equals -4. All right. Now, the domain then would be from -infinity to -4, and then jump over -4 and move on to positive infinity. So negative to positive, right? So there's what we're looking for that one. So list the equation of any vertical asymptote. That would be x, it's right here, x equals -4. All right, list the location of any holes of the function. There's no holes in this one. There's no elimination of the denominator when we simplify or anything like that. So it does, no holes exist. Determine the equation of the horizontal line as, horizontal asymptote, excuse me. So then because these are equal value, this one's first power, this first power, then they're the same. You take the leading coefficients and you go ahead and write it as a ratio. And that would be 4 over 5 because negative over negative is positive. So it's positive 4/5. Now that would be where it's y equals. All right, that's for the horizontal asymptote. You always put it as y equals. So there is the answer we're looking for that. Determine the x-intercepts. You let y equals 0. All right. So letting y equals 0, we can solve it. I would also venture to say we should maybe just use your graphic calculator just so that it's easier. some people don't like solving things in terms, so I'm going to just support this way. And so I'm looking for where there's a 0 and it's at 0. Okay? 0, 0. There's no other value system that does that. I mean, we're looking for, we're looking for where y is equal to 0. So it's going to be 0, 0. Determine the, that's the x-intercept. And then, of course, determine the y-intercept. It's going to be the same at location at 0, 0. And then choosing any 4 additional x values, we can go ahead and just put that in using any one of those. We can just go ahead and do this, right? It all depends on what input you use. So, that's why it's going to say something like this. Any x value needs to be entered. So I can just go ahead and put in negative 2. And then I just copying whatever's there. And then I'm just going to go ahead and put in fraction and then put in as -4 fifths. All right. So then I could check my answer. All right. Any value, and so then you can't really determine it, and you just have to check your answer. And you should be able to just copy, right? I mean, if I put in -1. All right, and then I put in the other values, and I'll let you guys do that, but that's not hard to do. That's why I said it's really nice just to put it in your graphing calculator. Okay, so use your graphing calculator there. Now, once you do that, you know your vertical asymptote, you know your horizontal asymptote. You can choose which graph represents this, but then you can also go ahead and hit this here and see that it looks like that one doesn't qualify for that. This one doesn't either. This one looks like it could, and this one looks like it possibly could, but wait a second, this is on the wrong side. It has to be this one. All right, and that it is. Okay, so using a graph is really important. Okay. Now we get into polynomial inequalities. Now, the first thing you want to do is make sure you put it in order from least to greatest, just like you do any other equation. And then remember that once you graph it, that wherever the graph is, it's going to be less, the answer is going to be wherever the graph itself, the physical graph, is less than 0. So, or below the x-axis. So what you do is you come into your graphing calculator and you punch in the equation. You hit graph, and you see that right here, look at this. I mean, seriously, the graph is above the x-axis the entire time. All right, if you let's go ahead and do zoom standard. The graph never comes across the x-axis. All right, so this says, where is this graph less than 0? Does not exist. There's no solution. All right, that's the answer. So it's that simple. I just don't understand why people think this is so complicated. I can go ahead and literally put that in as it's presented, and I can read it and understand it. But I like giving you consistency. Put it in order from least to greatest. That's what I want to teach you. Just keep it in order. And the last question I want to go over with you is question number 40. All right. So now we go ahead and look at this, right? And I go ahead immediately and want to bring everything over to the left side. So I'm going to make it. And the reason why I do that is because I want to I like my leading coefficient positive. I don't like not having my leading coefficient positive. So I do this, and then I have negative 15 is at the end, and it's greater than or equal to 0. So now I'm above the x-axis, and I'm equal to it as well. So I'm going to punch it in my graphing calculator. And then I'm going to graph it. And I'm asking, where is this graph above or equal to the x-axis? Because that's what the inequality says right there. All right. So I can see that I'm crossing over some points here. So I'm going to go ahead and quickly look at my graph and see, well, I know I have a crossing point at -1. And I also know that I have some point that exists between 0 and 1 because I have a change in signs here. It goes from negative to positive. So I want to calculate that value by simply just going ahead and saying second trace gives me calculate, and I want a 0 that's existing somewhere between this point and this point, above and below the x-axis on that. I want to hit guess, and I'm looking at that value, and I see that it says 0.75. Now I know 0.75 is 3/4, like 3/4, right? So now where does this thing above and below is from? Now I got to remember it's from -1, so it's negative infinity to -1 inclusive, and then I'm going to pick it back up at inclusive. Remember, inclusive 3/4, and then to infinity. That's when it's above and equal to the x-axis. And those are my answers. So I'm going to put that as my answer here. And then, of course, graphing it. Just be careful with the 3/4 when you graph with 3/4. I'm curious how sensitive it is. So I'm going to put that, and I'm going to draw a line from here to here. All right. And then I'm going to put another one from 3/4. Now that's going to be right about there. I wonder how sensitive it is. That looks like 1/2. I'm curious as to whether or not that's going to be acceptable. I don't know how sensitive it is. All right. I didn't put this answer in, but I'm not going to. I just want to see. And it looks like I did get this one partially correct. So, interesting. I want to go ahead and clear all, and I want to see if I can get it to be better. So then okay, that does look better. Okay, so it is sensitive, so be careful with the sensitivity of that. All right, so just make sure that you get that. I don't like the way I just did that. That was a little bit not good here. Let me see. And there we go. Let's see. And I know the first answer is going to be wrong. I don't care about that one. So I did get, so it is sensitive. I did get that one right. All of it's right now. I put it at 1/2 and it didn't work. So I was just curious. I mean, I knew the answer. It's 3/4, right? So anyway, just going ahead and clowning around a little bit. But that is the review that I wanted to go over with you and making sure you're ready for the test. So good luck with your test. Make sure you're working hard this week and you'll be successful.